It is extremely important for algebra to be able to recognize factoring problems and what technique to use when factoring them. So here are some factoring problems. Which one do you want to factor as a trinomial? A, B, C, or D? Which one as a difference of two squares, which is just a special trinomial where the linear term is 0? Which one is a greatest common factor? And which one is none of those? And you might want to use the quadratic formula or something called completing the square or some other method. So write down which one do you think is going to be a trinomial, A, B, C, or D. Difference of two squares, A, B, C, or D. Greatest common factor, A, B, C, or D. And none of those, A, B, C, or D. And we'll see which one is correct. So here, is a question. This was problem A. And I immediately say difference of two squares? Never, because this is not a difference problem. Difference means subtract. So is it a trinomial? No, because trinomial means there are three parts, and we only have two parts. And it's not a special trinomial that's the difference of two squares where the linear term is 0. Is it the greatest common factor? Yes. The first term and the second term have a common variable, which is w, so we're going to use a GCF because there is a common term, and that's w, or there's a common element in each term, and that is w. Okay, so what do? Well, we take a look at it and we say they have w in both parts. We're going to divide everything by w. There's not a number, a leading coefficient with w squared, but there is with 12w. So we can't put a number here because there's no leading coefficient there. There's no leading number there. No leading number, so we can't have a leading number there. Now I ask myself, w squared divided by w is w. Bring down the operation. 12w divided by w is 12. 12w divided by w, or divided by 1w, is the same as 12 divided by 1 times w divided by w. We can break them into two fractions, and that's exactly what I did here. Just the opposite of multiplication. If we were reading from right to left, it'd be true, so the same thing is true from left to right. We know w divided by w is just 1, so it's 12 over 1 times 1, which is just 12 divided by 1, and we all know that is 12. Okay, so that's why that's 12 right there. How do I know I am complete here? This can't be factored because it's not a trinomial, it's not a difference of two squares, and there's no common factor between 12 and w. There's no variable that's the same, there's no number that's the same. So this is a GCF. B. Well, I ask myself, is it a greatest common factor? Is there a letter that goes into x squared and 12x? So far it's x, but 20? No, there's no letter that goes in there. Okay, now, is there a number that goes into x squared and 12 that's the same? Only the trivial case, which is 1. So there's not going to be a greatest common factor. It's not a difference of two squares because there are three things. Oh, why didn't I try that first? There are three things. It's a trinomial. So if I'm going to use this as a trinomial, the question that you have to ask yourself, is there a number that multiplies to be 20 with a sum of 12. Well, I shouldn't say is there a number, but is there a pair of numbers? Remember, factoring is breaking it into its product parts, so it's the opposite of distribution here in all the cases. So is there a number that multiplies two numbers that multiply to be 20 and add up to be 12? Well, you can list all the numbers or all the pairs of numbers that multiply to be positive 20 and add up to be positive 12. I did that backwards with 2 and 10, but that's okay. I should have done 10 and 2, just if I'm going to go with the smallest one or the largest one. So 2 times 10 is 20. They multiply and they add up to be 12. 3 doesn't go into 20, 4 and 5. So these are the three sets. We're going to use this one. The answer is exactly what that is. It's positive 2, so we put plus 2, and we put x plus 10. Well, that's nice, Mr. Bryce, but I don't understand where that's coming from. This is telling us that when we multiply x plus 2 together and x plus 10, we're going to get x squared plus 12x plus 20. If we have a rectangle whose height is x plus 2, x feet plus 2 feet, and we have a width of x feet plus 10. We want the width to be so much more than the height. So when we multiply these together, if I take x times x, this is telling me that this part of the garden is a square whose height is x feet and whose width is x feet. So the area is x times x, or x squared. Now this is only 2 feet tall, but it's still x feet wide. So the area of this rectangle here is 2 times x, or 2x. The area of this rectangle here is x high and 10 wide, so the area is 10 times x, or just 10x. The height of this is 2 feet, the width is 10, so the area is 2 times 10, or 20 feet. So the total area of this rectangular garden is x squared plus, you saw me draw this arrow here, 10x plus 2x is 12x, so I can combine those to be 12x plus 20. So this method of factoring, saying that two numbers that multiply to be 20, this is where the product is, the length and the width, they multiply to be 20, and yet their sum, the area of this small piece and the area of this small piece, add up to 12, the middle term. Okay, makes sense. It's logical. There's no tricks here. This is a trinomial. You have to think of two numbers that multiply to be 20, add up to be 12. Leading coefficient is 1, and that's why this works. Question C, you say, well, Mr. Bryce, this is a trinomial, just like the previous example. It has 3 terms. Okay, so why don't I use the two numbers that multiply to be 3 and add up to -7 method? Well, I said the leading coefficient had to be 1. This leading coefficient is 2. Now you have to think, does 2 go into 2x squared? Yes. Does it go into 7? No. Does it go into 3? No. This is not a greatest common factor. It's not a difference of 2 squares because there are 3 things. It's not, even though it is a trinomial, we can't factor it using the trinomial method. This one, we're going to use the quadratic formula, which is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. You notice that our axis of symmetry equation is right there, x equals negative b over 2a. A is the number of the leading coefficient in front of the x squared, b is our linear term, and c is our y-intercept. I plugged in the numbers quickly. Now you remember that the negative of a negative is just a positive 7 plus or minus the square root. Negative 7 squared is 49 minus 4 times 2 is 8 times 3 is 24 all over 2 times a, 2 times 2 is 4. 49 minus 24 is 25. The square root of 25 is 5. So 7 plus or minus 5 all over 4. Now, let's just say it's 7 plus 5 over 4, or 7 minus 5 over 4. 7 plus 5 is 12 over 4, which is 3. 7 minus 5 is 2 over 4, which is also 1/2. We have two answers, and that's what they are. What caused the problem? That 1/2 right there. If you have any questions, make sure you ask me in class. D. First thing that I recognize is that it's a subtraction problem. Second thing that I recognize is that there are only two parts to it, so I think difference of two squares. The third thing that I think then is 9 a perfect square. Yes, the square root of 9 is 3. The square root of x squared is x. What's the square root of 100? The square root of 100 is 10. Why does this work? Well, I said this was a special trinomial. 9x squared plus 0x. Sorry for that interruption. I'm not quite sure where we were, but let's just back up a little bit and say that this is a special trinomial where the linear term is 0. So we have 9x squared plus 0x minus 100. I say it's a special trinomial because that's 0. 0 times anything is nothing, so that's why it's missing in that part. So let's try to use the area model again. But this time, let's say that's 9x squared. Remember, this portion here is truly a square from our earlier example. The height is the same as the base, so a number times itself has to equal 9x squared. Well, 3 times 3 is 9, and x times x is x squared. Now, these two terms have to add up to be that center part. They have to add up to be 0. So whatever they are, they have to be opposite each other. And they have to be exactly the same number. This part down here multiplied to be negative 100. So to multiply to be negative 100, they can be 1 and 100, 2 and 50. Let's just make those negatives. 4, negative 4 and 25. Negative 5 and 20. Negative 10 and 10. Now remember, I said that they have to add up to be 0. The only set of numbers that adds up to be 0 is negative 10 and positive 10. Okay. So if we take the square root of 100 and the square root of 9x squared, we're going to get the difference of two squares. 3x minus 10, 3x plus 10. Remember that there are two roots to that. Let's do a quick summary. Here's some factoring methods. I recognize this as a GCF, greatest common factor, because they both have a W term in it. I recognize this one as a trinomial because there is no leading coefficient in front of the x squared. Or I apologize to those people who are in for detail. It's a 1 is the leading coefficient. The number ax squared, plus bx plus c. The a is 1. We can use the trinomial method because there are 3 parts to it. As long as we can think of two numbers that multiply to be 20 and add up to be positive 12. If not, we'll have to use the third method. This method here, which is using the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember that this part here is the same as our equation for the axis of symmetry. This one is the difference of two squares because it's a subtraction problem, and 100 is a perfect square. 9x squared is a perfect square. If you have any questions, make sure you ask me tomorrow in class or at any time. Thanks, and have a great night.